Hello and welcome to this exciting crash course on the fundamentals of Python. In just 30 minutes you'll gain a solid understanding of this versatile and powerful programming language. Whether you're a complete novice or have dabbled in coding before, this course is designed to equip you with the essential knowledge to embark on your Python journey. Python is renowned for its readability and beginner-friendly syntax, making it an ideal choice for those taking their first steps into the world of programming. It's like learning a new language, but this time you'll be talking to computers. Throughout this crash course, we'll explore the core concepts of Python. From variables and data types to control flow and functions, we'll use clear explanations, illustrative examples, and hands-on exercises to ensure you grasp each concept effectively. So, buckle up and get ready to unlock the exciting world of Python programming. Let's dive in. Python's versatility is truly remarkable. It's used extensively across a wide range of industries and applications, from web development and data science to machine learning and artificial intelligence. Popular websites like Google, Instagram, and Spotify all rely heavily on Python for their functionality. In the realm of data analysis, Python reigns supreme. Its powerful libraries and tools such as Pandas and NumPy empower analysts and scientists to process, analyze, and visualize massive datasets with ease. From predicting customer behavior to uncovering hidden patterns in scientific research, Python is driving groundbreaking discoveries. The rise of artificial intelligence and machine learning has further propelled Python to the forefront of programming languages. Libraries like TensorFlow and PyTorch provide the building blocks for developing sophisticated AI models capable of tasks like image recognition, natural language processing, and even self-driving cars. Python's impact extends far beyond the tech industry. It's used in finance for algorithmic trading, in healthcare for medical imaging analysis, and even in the arts for creating stunning digital art and animations. With so many programming languages available, why choose Python? There are several compelling reasons why Python stands out as an excellent choice, especially for beginners. First and foremost, Python's syntax is incredibly readable and intuitive, resembling plain English. This makes it significantly easier to understand and write code, even for those with no prior programming experience. You'll be surprised how quickly you can start writing your own programs. Secondly, Python boasts a vast and supportive community of developers worldwide. This active community contributes to a wealth of online resources, tutorials, and forums where you can find help, share your knowledge, and connect with fellow Python enthusiasts. Thirdly, Python's extensive collection of libraries provides pre-built modules and functions for a wide array of tasks, saving you countless hours of coding from scratch. Whether you're building a website, analyzing data, or developing an AI model, there's likely a Python library ready to streamline your workflow. Finally, Python is a versatile language with applications in various domains, ensuring that the skills you acquire are highly sought after in today's job market. Learning Python opens doors to exciting career opportunities across numerous industries. Now that you're familiar with Python's capabilities and benefits, let's dive into the practical aspects of this crash course. We'll begin by setting up your Python environment and writing your first lines of code. Don't worry, we'll guide you through each step. Throughout this course, we encourage you to actively participate by typing out the code examples, experimenting with different inputs, and even challenging yourself to solve small coding exercises. Remember, the best way to learn programming is by doing it. We'll be using a combination of slides, code demonstrations, and interactive exercises to make your learning experience engaging and effective. Feel free to pause, rewind, or replay any section as needed to reinforce your understanding. Are you ready to embark on this exciting journey into the world of Python programming? Let's get started. Welcome back. In this section, we'll delve deeper into the diverse applications of Python, showcasing why it's often called the Swiss Army knife of programming languages. Python's versatility stems from its ability to adapt to a wide range of tasks, much like a Swiss Army knife with its array of tools. Whether you're interested in building websites, analyzing data, automating tasks, or even delving into the fascinating world of artificial intelligence, Python has the tools and libraries to empower your endeavors. One of the key reasons for Python's widespread adoption is its extensive ecosystem of libraries. These libraries are essentially collections of pre-written code that provide ready-made solutions for common programming tasks, saving you from reinventing the wheel. Need to perform complex mathematical calculations? NumPy has you covered. Want to manipulate and analyze data with ease? Pandas is your go-to library. Moreover, Python's simple and intuitive syntax makes it remarkably easy to learn and use. Unlike some programming languages with cryptic symbols and complex rules, Python reads more like plain English, allowing you to focus on the logic of your programs rather than getting bogged down in syntax. Let's start with web development, a field where Python truly shines. Python's frameworks such as Django and Flask have gained immense popularity for their ability to streamline the process of building websites and web applications. Django, a high-level framework, is renowned for its batteries-included approach, providing everything you need to build complex, database-driven websites right out of the box. From user authentication and authorization to URL routing and template rendering, Django takes care of the heavy lifting, allowing you to focus on building your application's unique features. Flask, on the other hand, is a micro-framework that offers a more minimalist approach, giving you greater flexibility and control over your application's structure. Flask is an excellent choice for smaller projects, APIs, or for developers who prefer a more hands-on approach to web development. Whether you're building a personal blog, an e-commerce platform, or a social networking site, Python's web development frameworks provide the tools and flexibility to bring your ideas to life. Next, we venture into the realm of data science, where Python has become an indispensable tool for analysts, scientists, and researchers worldwide. Python's libraries, such as Pandas, NumPy, and SciPy, form the backbone of data analysis, manipulation, and visualization. Pandas, with its powerful data frame object, enables you to organize, clean, transform, and analyze data with unparalleled ease. You can effortlessly import data from various sources, handle missing values, filter and sort data, and perform statistical analysis. NumPy, short for numerical Python, provides the foundation for numerical computing in Python. Its array object allows for efficient storage and manipulation of large datasets, making it ideal for tasks involving mathematical operations, linear algebra, and Fourier transforms. SciPy, building upon NumPy, extends Python's scientific computing capabilities with modules for optimization, integration, interpolation, signal processing, and more. Section 4. Automating the mundane. Beyond web development and data science, Python excels at automating repetitive tasks, freeing up your time and boosting your productivity. Whether you're tired of renaming hundreds of files manually or wish to automate data entry tasks, Python comes to the rescue with its scripting capabilities. Python's simple syntax and extensive libraries make it a breeze to write scripts that interact with your operating system, automate file operations, scrape data from websites, and much more. Imagine effortlessly renaming thousands of files, sending personalized emails to a large list of recipients, or downloading files from the web with just a few lines of Python code. Moreover, Python's cross-platform compatibility allows you to run your scripts on various operating systems, including Windows, macOS, and Linux, without making any significant changes to your code. Section 5, your Python journey begins. As we've seen, Python's applications are vast and varied, spanning from web development and data science to automation and beyond. Its versatility, combined with its beginner-friendly syntax and supportive community, makes it an ideal language for both beginners and experienced programmers alike. In the upcoming sections of this crash course, we'll dive into the practical aspects of Python programming. We'll explore the fundamental building blocks of the language, including variables, data types, operators, control flow statements, and functions. Get ready to embark on an exciting journey into the world of Python programming. Section 1. Building blocks, variables, and data types. Let's explore Python syntax with variables and data types. Variables are like labeled containers for information. Store numbers, text, or lists in variables. Create a variable by naming it and assigning a value. For example, age equals 25. Data types define the kind of information variables hold. Python has several built-in data types. Integers are whole numbers. Floats are numbers with decimal points. Strings are sequences of characters. Booleans represent true or false. Data types determine operations on variables. You can add integers, but not an integer to a string. Section 2. Numbers in Python, integers and floats. Numbers form the backbone of many programs, and Python provides excellent support for working with both whole numbers, known as integers, and numbers with decimal points, called floats. You can perform all the standard arithmetic operations on numbers in Python using the following operators: plus for addition, minus for subtraction, asterisk for multiplication, slash for division, double slash for floor division, which returns the quotient of a division, discarding the remainder, percent for modulo, which returns the remainder of a division, and double asterisk for exponentiation, which raises a number to a power. For example, 5 plus 2 will result in 7, while 10 divided by 3 will give you 3.33333333335. The floor division operator, double slash, is useful when you only need the whole number part of a division, so 10 floor divided by 3 will return 3. Remember that when you divide two integers using the slash operator, the result will always be a float, even if the division is exact. Section 3. Textual information strings and their operations. Strings are the workhorses of text manipulation in Python. You can think of strings as sequences of characters, and Python provides a rich set of operations for working with them. Creating a string is as simple as enclosing the desired characters in single or double quotes. For example, message equals hello Python creates a string variable named message containing the text hello Python. You can access individual characters within a string using their index, starting from 0. For instance, message bracket 0 would return the letter H, and message bracket 7 would return the letter P. Python provides several built-in methods for manipulating strings, such as len of the string, which returns the length of the string, string.upper, which converts the string to uppercase, string.lower, which converts the string to lowercase, and string.replace old with new, which replaces all occurrences of old with new in the string. Section 4. Storing collections lists and their manipulation. Lists are versatile data structures in Python that store collections of items in order. Think of a list as an ordered container holding mixed data types. Create a list with square brackets separating items by commas. Access items using their index, like my underscore list 0 for the first item. Python offers methods like append, insert, remove, and sort for list manipulation. Section 5. Data preservation, comments in Python. As your code becomes more complex, it's essential to maintain its readability and understandability. This is where comments come in handy. Comments are lines of code that are ignored by the Python interpreter, meaning they don't affect how your program runs. Their primary purpose is to explain what your code is doing, making it easier for others, and your future self, to understand. In Python, you can create comments using the hash symbol. Anything following a hash on a line is considered a comment and is ignored by the interpreter. For example, print, this line is code and will be executed. Hash, this is also a comment. Comments are invaluable for documenting your code, explaining complex logic, and making your code base more maintainable. Section 1. Controlling the flow. Introduction to Control Flow. Welcome back, Python explorers. In this act, we'll delve into the heart of programming logic, control flow. Imagine you're navigating a maze. You wouldn't just walk in a straight line hoping to reach the end. You'd make decisions at each turn, choosing the path that leads you closer to your goal. Control flow in programming is very similar. It allows you to dictate the order in which instructions are executed in your programs. Instead of executing code line by line from top to bottom, you can use control flow statements to introduce decision-making, repetition, and logical branches in your code's execution path. Python provides a powerful set of control flow statements, including conditional statements, allow your program to execute different blocks of code based on whether certain conditions are true or false. Loops enable you to repeat blocks of code multiple times, either for a fixed number of iterations or until a specific condition is met. By mastering control flow, you'll empower your programs to respond dynamically to different situations and perform complex tasks efficiently. Let's explore these concepts in detail. Section 2. Decision-making with if, elif, and else. The and statements form the foundation of conditional execution in Python. They allow your program to evaluate conditions and execute different blocks of code depending on whether the conditions are true or false. Here's the general structure of an block. If condition 1, let's break down how this works. 1. The statement starts the block and evaluates the condition specified after it. 1. If is true, the code indented under the statement is executed, and the rest of the block is skipped. 1. If is false, the statement short for else if is evaluated. 2. If the condition is true, its corresponding code block is executed. 3. You can have multiple statements to check for various conditions. 4. Finally, if none of the OR conditions are true, the code under the statement, if present, is executed. For example, let's say we want to write a program that determines if a number is positive, negative, or zero number equals sign float, input, enter a number. If number 0, print, the number is positive. Elif number 0, print, the number is negative. Else, print, the number is 0. In this example, the program takes a number as input and uses to print an appropriate message based on the number's value. Section 3. Repetition with for loops, iterating over sequences. Loops are essential for repeating blocks of code multiple times. The loop in Python is particularly useful for iterating over sequences of elements, such as strings, lists, or ranges of numbers. Here's the general structure of a loop for item in sequence. 1. The keyword initiates the loop. 2. Is a variable that takes on the value of each element in the as the loop iterates. 3. The keyword connects the variable with the being iterated over. 4. That can be any iterable object, such as a list, string, or range. 5. The code indented under the statement is executed for each in the, for example, let's print each letter in the word Python. For letter in Python, print letter. This loop will iterate over each character in the string Python and print it on a separate line. You can also use the function to create sequences of numbers for your loops. For instance, to print numbers from 1 to 5 for I in range 16 hash range 16, generates numbers from 1 to 5, exclusive print I. Section 4. Conditional iteration with while loops. While loops are great for iterating over sequences, loops provide more flexibility for repeating code based on a condition. They continue to execute a block of code as long as a specified condition remains. Here's the general structure of a loop. While condition: 1. The keyword starts the loop. 2. The is evaluated before each iteration of the loop. 3. If the indented code block is executed. 4. This process repeats until the becomes. It's crucial to ensure that the eventually becomes within the loop's body. Otherwise, the loop will continue indefinitely, leading to an infinite loop. For example, let's write a program that counts down from 5 to 1, countdown =5 while countdown 0, print countdown 1 hash, decrement countdown by 1 in each iteration print blast off. In this example, the loop continues to print the value and decrement it by 1 until becomes 0. Then the loop terminates and blast off is printed. Section 5. Nesting loops and conditional statements. You can combine loops and conditional statements to create more complex control flow structures. Nesting one control flow statement inside another allows you to perform intricate operations and build sophisticated logic. For instance, you can nest a loop inside another loop to iterate over elements in multiple sequences. Here's an example to illustrate: outer underscore list equals sign, 1, 2, 3, inner underscore list equals sign, AB for outer underscore item in outer underscore list, for inner underscore item in inner underscore list, print outer item inner underscore item. This code will print all possible pairs of items from the AND. Similarly, you can nest blocks inside loops, loops inside blocks, or any combination of these to achieve the desired control flow for your program's logic. Section 6. Practice makes perfect control flow exercises. Congratulations on making it this far. You've learned about control flow statements in Python. Now it's time to put your knowledge into practice. Here are some coding exercises to solidify your understanding. 1. Even or odd. 2. Sum of numbers. 3. Factorial. 4. Prime number. Remember, the key to mastering programming is practice. Try these exercises and feel free to explore other coding challenges online. The more you code, the more confident you'll become in your Python skills. Section 1. Functions, the building blocks of reusable code. Welcome back, Python enthusiasts. In this act, we'll explore one of the most powerful concepts in programming: functions. Think of functions as self-contained blocks of code that perform specific tasks, much like mini-programs within your larger program. Imagine you're baking a cake. You wouldn't write down the entire recipe every time you needed to mix ingredients or preheat the oven, would you? Instead, you'd have separate instructions for each task, which you could refer to and reuse as needed. Functions in programming work similarly. They allow you to encapsulate a block of code, give it a name, and then execute that code whenever you need to perform that specific task. This promotes code reusability, modularity, and organization, making your programs easier to read, maintain, and debug. Python provides a wealth of built-in functions, like and, which we've already encountered, but the true power of functions shines when you start defining your own, tailored to your program's specific needs. Section 2. Defining your own functions with def. In Python, define functions using the keyword, followed by the function name, parentheses, and a colon. The indented code block under the definition is the function's body. Example: def greet underscore user. Print, hello there. Call it with greet underscore user to execute. Section 3. Passing information to functions arguments. Functions become even more versatile when you can pass information to them for processing. This is where arguments come in. Arguments are values that you provide to a function when you call it, allowing you to customize its behavior. In the function definition, you specify parameters as placeholders for these arguments. When you call the function, you provide the actual values within the parentheses. These values are then assigned to the corresponding parameters inside the function's body. Let's modify our function to accept a name as an argument. Python def greet user name prints a personalized greeting message. Print hello name. Now when you call, you need to provide a name within the parentheses. This name is then used within the function to print a personalized greeting. You can have multiple parameters in a function definition, separated by commas. When calling the function, you provide the arguments in the same order as the corresponding parameters. Section 4. Returning values from functions. While functions can perform actions and print output, they can also be designed to return values to the code that called them. This allows functions to act like data producers, sending back results that can be further used in your program. You use the keyword within a function's body to specify the value to be returned. Once a statement is encountered, the function execution stops, and the specified value is sent back to the caller. Let's create a function that calculates the square of a number and returns the result. Python def square number calculates the square of a number. Return number asterisk number print, the square of 5 is our result. In this example, the function calculates the square of the input and returns the result using the statement. The returned value is then assigned to the variable and printed. If a function doesn't have an explicit statement, it implicitly returns, which represents the absence of a value. Section 5. Functions, calling functions, a collaborative approach. Functions often work together to accomplish tasks. One function might call another to handle a subtask. Let's illustrate this with an example. Write a program to greet a user and tell them the length of their name. Break it into two functions, getName length name, and greetUser with name length name. Get underscore name underscore length returns the length of a name. Greet underscore user underscore with underscore name underscore length greets the user. Name underscore length equals sign, get name length name print, vef, hello name, your name is, name underscore length characters long, user underscore name equals sign input, enter your name. This demonstrates how functions can work together. Functions calling other functions is fundamental in programming. Congratulations on completing this whirlwind tour of Python basics. In just 30 minutes, you've journeyed from the fundamental building blocks of variables and data types to the expressive control flow of loops and conditional statements, culminating in the elegant power of functions for reusable code. Remember those initial lines of code you wrote? What seemed like cryptic symbols just a short while ago are now familiar tools in your programming arsenal. You've grasped the essential concepts that empower you to write programs capable of making decisions, repeating actions, and processing information, the very essence of programming. As you've seen, Python's syntax is designed to be readable and intuitive, making it easier to translate your ideas into code. You've learned how to create variables to store data, use operators to perform calculations, and employ conditional statements to control the flow of execution based on logical conditions. But this is just the beginning of your Python adventure. The real excitement lies in exploring the vast landscape of Python's libraries and frameworks, each a gateway to a world of specialized capabilities. Imagine building interactive websites with Django or Flask, delving into the depths of data analysis with Pandas and NumPy, or even training your own machine learning models with TensorFlow or PyTorch. These are just a glimpse of the possibilities that Python unlocks. Python's versatility and extensive ecosystem make it an ideal choice for a wide range of applications, from automating mundane tasks to creating cutting-edge technologies. Whether you're passionate about web development, data science, artificial intelligence, or any other field touched by programming, Python provides the tools and resources to turn your ideas into reality. Section 3. The learning never ends. As with any new skill, the key to mastering Python is continuous learning and practice. The more you code, the more comfortable you'll become with the language's syntax, idioms, and best practices. Don't be afraid to experiment, make mistakes, and learn from them. Every error is an opportunity to deepen your understanding and become a more proficient programmer. Embrace the iterative nature of coding, where each iteration brings you closer to an elegant and efficient solution. Fortunately, you're not alone on this journey. Python boasts a vast and welcoming community of developers, both online and offline, eager to share their knowledge, answer questions, and provide support. Section 4. Embrace the Pythonic Way. As you progress in your Python journey, you'll encounter the concept of Pythonic code, code that not only works, but also adheres to Python's philosophy of readability, simplicity, and elegance. Pythonic code is concise yet expressive, favoring clear and intuitive solutions over convoluted workarounds. It leverages Python's built-in functions and libraries to their fullest potential, resulting in code that is both efficient and a joy to read. Embrace the Zen of Python, a collection of guiding principles for writing beautiful, idiomatic Python code. You can access it directly from your Python interpreter by typing. Let these principles guide your coding style as you strive for clarity, simplicity, and elegance in your programs. Section 5. From beginner to Pythonista. Remember, every expert programmer was once a beginner, taking their first steps into the world of coding. The journey from novice to proficient Pythonista is a gradual but rewarding one. filled with challenges, triumphs, and moments of aha as concepts click into place. Be patient with yourself, celebrate your progress, and never stop exploring the vast possibilities that Python offers. The more you invest in learning and honing your skills, the more empowered you'll become to create innovative solutions, automate tasks, and bring your ideas to life. So, keep that code flowing, embrace the challenges, and never stop learning. The world of Python programming awaits, and with your newfound knowledge, you're well equipped to embark on an exciting and rewarding journey. Section 6. Keep the code flowing. As we conclude this 30-minute crash course, remember that the learning doesn't stop here. The world of programming is constantly evolving, with new libraries, frameworks, and tools emerging all the time. Make it a habit to explore new Python concepts, experiment with different libraries, and challenge yourself to build increasingly sophisticated projects. The more you immerse yourself in the Python ecosystem, the more proficient and versatile a programmer you'll become. And most importantly, have fun along the way. Programming is a creative and rewarding endeavor, allowing you to turn your ideas into reality, one line of code at a time. Embrace the joy of problem solving, the satisfaction of building something from scratch, and the thrill of seeing your code come to life. Keep that code flowing, and who knows what amazing things you'll create with Python.